Hello and welcome to this tutorial on Suse Enterprise Storage 6. Everything is given here from start to finish, so you can follow along with these and set up your own configuration. I've used virtual machines, but you can also use physical machines as well, or you may use a different hypervisor than the one I'm using. You will need codes or trial software from Suse to do this, so you can either deploy it or you can follow along by just looking at the video. And thanks for watching. So the configuration that we want to deploy here will have a total of 5 machines. These machines are all named Suse 00, Suse 01, so on, right up to Suse 04. All the nodes will have 3 interfaces. The first network face will be DHCP. The next 2 will be used for the Ceph public IP and the Ceph private IP. You can see that the IP static names are very similar. The third octet on the public IP is 16 and on the private IP it's 17. In addition, we're going to use Suse 04 as the admin node, so this will be running the SOAP master. And then what we'll do is we'll use the other 4 nodes for OSD storage and a number of other functions. So this is a little bit overloaded, and typically in a real production environment you'll have more nodes to scatter things out, and typically more OSD storage nodes as well. In this configuration we're using VMware Workstation to configure our virtual machines. The simulated hardware is shown here. We have 3 network adapters, one for DHCP internet access, another for the Ceph public network, and the third for the Ceph private network. Later on we'll add more disk drives to be used as OSDs. Currently we've got 4 gigs of RAM and we're simulating 4 processors within the system. I've also loaded the Suse operating system ISO image into the virtual CD. You can see that as the third line item above the highlighted network adapters. Okay, in this section we're going to install the operating system. We'll do this on one of the nodes and then we'll leave the other nodes up to the installer to do that themselves. So when the system boots, we want to select installation, press enter. It should take a few moments just to load some text files and then we'll get into the GUI. So we're just starting the initializing process here. Alright, so I'm going to select Suse Linux Enterprise Server with Service Pack 1, which is our operating system. And then we'll leave it at that and we'll carry on. In my case, I'm going to use the US keyboard, so that may or may not be appropriate for you. So we'll select next. Agree to the license terms and select next. You will need a code here for the registration, so I'm going to enter my email address and the registration code that I have associated with it. So when we get to the available extensions and modules, we are going to add in Suse Enterprise Storage 6, and as well as that we're going to add in the desktop applications module. This allows us to boot up into GNOME as well. Once this is done, we can select next. Again, it'll contact the registration server, agree to the license terms, This takes a few moments while it does that. All right, we can skip the additional add-on products. We're going to use Enterprise Linux with GNOME, so that's fine. We'll take the default layout for the disk. You can see that it uses ButterFS and a couple of other file systems. In my case, I'm going to use the Eastern Coast time zone. We need to create a user. I typically use the username Ceph user. I don't take the default of username Ceph because that can be confusing when later on you look at some of the Ceph processes, so I simply call it Ceph user. We need to set up a password. And then I typically use the same password for the admin. This is something you probably wouldn't want to do in a production environment. And select Next. We do need to make a few changes at this stage. Software looks good. We're going to need to make some changes to network configuration. So we'll use DHCP for ETH0. That's fine as it's set up. We'll change the host name. Default is Linux, so we'll get something a bit more meaningful. We're going to use for the first node Suse 00, and then next node to be 01, 02, and so on. And we need to set ETH1 to be a static. So we're going to use the 10.10.16 network with a network mask of 255, 255, or 24. And we need to also change the static to a static for ETH2. What we'll do is we'll change the third octet to be 17, otherwise everything else will stay the same. Network mask of 24. And that looks good. After configuring the network, we need to go in and change the firewall settings. Here we'll disable the firewall, and then when everything's up and running, then the system needs to be set up according to the organization's security policies. So what we'll do is we'll temporarily disable the network, and then we can enable it again with the various ports that are required for Ceph. In addition, we'll make sure that SSH is enabled. That's something that we're going to need as well. So that looks good. And then the system should start the installation, and then afterwards we'll reboot. Depending on whether you're using physical hardware or not, if you're using virtual machine software, you may need to bring down the nodes to add the disks. So in this case, we're going to add two OSD devices for each of the systems. So we'll bring down the nodes, and then what we need to do then is to go into the virtual machine settings, and we need to go in and edit them to add hardware. So we click on settings, then we click on add, hard disk. We're going to make it NVMe. Create a new virtual disk. We'll leave it at the 20 gig default. Store it as a single file. Select next. And then we'll add a second node in. NVMe again. So now we should have two physical NVMe devices that will be available for OSD node. So now we can start up our virtual machine and we should be able to see those devices. So now that the system has been installed and that we've brought down our systems and we've added in the OSD devices, we need to do a little bit of configuration. So the first thing we want to do is edit the etc host file so that the admin node, which in our case will be Suse04, will understand all the node names of the remaining nodes as well. Incidentally, I'm using a utility called Tilix, which you can get, which allows you to type commands in one window, and this can be synchronized in the other windows. So as I start using it, you'll see how it works. Just do a simple Google for Tilix, and you can see how to install it under the Suse operating system. So you can see in the etc host file, I've actually added in the fully qualified domain names as well. So if we didn't do this at the network installation screen during the installation, we can go in and edit the etc host file on each of the different nodes. So now that we've done that, we'll go in and log into each of the different windows. So on the first one, we're going to log in to node Suse00. On the second window, we'll log in as Suse01. And as I said, with this utility, when we synchronize the windows, we can issue common commands in one window, and that will be copied automatically to the others. So it saves a lot of typing. Of course, you don't need to do this. You could also cut and paste and just use a regular terminal. If you don't have as much screen real estate, you could just simply SSH into each of them, whatever really suits your preferences. All right, let's just log on to the last one, Suse0003. And we have them all logged on. So we need to also copy the etc host file across to each of the nodes so they're all aware of each other. This is something we need to do. This is how you synchronize the input. So now any commands we type in one will be echoed to all the others. Some of the commands will be local, but let's just check to see if all the disks are there. So lsblk, we've just typed on one window. It's been echoed to everything else, and you can see the NVMe devices on all the other nodes. So we have 10 OSD nodes that will be available to us later on during the configuration. We'll just undo the synchronize window because we want to type in some commands that are specific only to the admin node Suse04. So what we're going to do now is we're going to go in as a super user because some of the things we'll be doing will be privileged. We want to copy across the etc host file to each of the other nodes as well. So scp/etc/host to the node name and then to statc/host. So we're going to overwrite all those as well. So the first one is Suse00. We'll just do it for them all. And I'm using the 10.10.16 network to communicate with each of these. You could have a dedicated network, or you could have set up static IPs really on the management side with manual gateways and DNS servers and all those other configurations. But for our purposes, this is fine. We can simply use this to communicate with when we're talking to each of the different nodes. So we did mention as well that the host name may need to be modified to suit the etc host file. So if we look at this one, we have the basic node name, but we want to include the fully qualified domain name. So I'm using excelsis.io for this. So all the other nodes will have to be configured similarly. So Suse01 will be Suse01.excelsis.io and so on. I just temporarily switched to super user mode in all those windows. We need to do some common functions. The first thing we'll do is do an update, just to check for the latest software. This should be pretty well up to date because when we did the installation, we did specify to pull in the latest repositories, so there shouldn't be too much work to do on this, but it's a good practice ready to do this, especially now that we've got all the systems done. Okay, so that shouldn't take too long. Okay, just a couple more out of sync. This is all done asynchronously, of course, so you can't really be sure which one will finish first. Looks like we're just waiting on Suse04 to finish. It shouldn't take too much longer. Sorry, Suse00 to finish. Alright, we can exit out of super user mode, so we're back in. Also on this one, we need to exit from Suse04, but let's just turn off the synchronize window so we don't log ourselves out of all the other nodes inadvertently. Alright, so we're back in as the Ceph user, and what we need to do next is to generate some keys so that we can have passwordless login. So on the admin node only, let's generate the key and we'll take the default locations. So the key is now being generated. And what we need to do is we need to copy that key across to all the other nodes. So we'll just do a simple for loop to do this as well. So this is one of the benefits of naming the host names in a nice sequential way. It aids us out very well to doing these loops. So not only do we want to copy the key across to the other nodes, we need to copy it across to ourselves as well. So you can see the nodes there, 0 right through to 4 are covered. So we put in the node name with a $I variable. And we'll follow that up with done. Oops, I think we forgot the semicolon after the Suse $0.1. So let's just go and edit that. Okay, so there we go. All right, I think this is the last node coming up. And let's just put that in. Okay, we can verify that. So what we should do is just check this out as well. So we'll use node Suse02 just to see if we can log in, and there we go. So we weren't prompted for any password. Everything worked out just fine.
So the next task is to configure the time service. So we'll start up some system services. Next, we'll just make sure that this persists across boots. So we will enable the service. Now with NTP we can use YAS to configure this. Oops, again, privileged command. So we'll go to Network Services, and then we'll go to NTP Configuration. And you can really see the power of synchronizing this across all the different nodes. We can just enter the commands once and everything will work. So we're happy with now and on boot. And then we want to come down and do add. Oops. We can hit the tab key with add selected. Okay. So we want to select public server. So we'll hit the tab key to select. We'll do public server. Select the region. In my case, it's going to be USA. So I can take a list of NTP servers there, and we'll take the default one offered, which is located, looks like, in Arizona. So select OK on that one. And then we'll hit the tab key to select OK. So there's our server. Select OK again. Alright. So next we want to do is to install the SOAP master on the admin node, which in our case is Suse 04. So we'll turn off the little synchronization button here, and we'll enter the command So this is part of the enterprise storage repositories that we've installed. So it should pick it up. Fine and yes. So the SOAP master is what we'll use to control our deployment of Ceph to all the other nodes. So the master is really the administration, and then the other nodes are known as SOAP minions. So what we need to do next is we need to install the SOAP minion package on all the nodes. So I'll turn back on the synchronization flag or button, and you can see now that's there. So we'll need to do a similar command, sudo install SOAP-minion. Some of the minion nodes will take a little bit longer because some of the extra packages were already installed on the admin node. Incidentally, we need to install SOAP minion also on the admin node because we're going to use Suse 04 for a number of services as well. You can also see that Python 3 is being deployed with this later version. Alright, that seems to be pretty well everything. Okay. The next task is to edit the file salt/minion. So we'll do sudo vi/etc/salt/minion. And we need to scroll down a little bit here. And we want to look for the string master. You can see it's here. So we'll uncomment that. And then we'll change the node name to say Suse04. And we'll save that file. So editing that file allows the minions to know who the salt master is. So we need to now go back to the admin node Suse04 and on this screen only start up the salt master. So the salt master should now be running. We'll also enable it so that this will persist across boots. Alright, and we'll turn back on synchronization. Just clear all the systems. Alright, so the next job is to do sudo system control start salt-minion. So we're going to start up the minions on all the nodes. All the nodes except the admin require sudo password, so let's put that in. Okay. Just again, we want this to persist across boots, so we'll enable the salt minions. Okay, and finally we'll just do sudo system control status, pipe that into grep, and we'll look for the term salt. So if you look there, we can see on the admin node salt masters running as well as the salt minions, and on all the other nodes the minions are running. The next command we want to do is only on the admin node, so again turn off synchronization. And we type in this command salt-key-uppercase F. Privilege command. You can see that all the nodes have been picked up, Suse00 right through to 04. These are unaccepted keys, so the system is aware of them, but it hasn't entered them in. So what we need to do is to accept all these keys. So the command for that is sudo salt-key -accept-all. You could put the individual names, or you could just accept every one of them as we're doing. Okay, accept unaccepted keys, proceed. Yes, we do want to. And now we can come along and we can go back to that command we had earlier. And you can now see that all the keys have been accepted. So earlier we added into virtual NVMe devices using VMware Workstation. If you're using physical hardware, your drive availability may differ, but the principles are very much the same. So let's just list those devices. So you can see they're here: NVMe 0N1, NVMe 0N2. Let's just change the super user temporarily. We want to do a few privileged tasks here. So this command that I've just pasted in does a little loop here. It says for drive ID 1 to 2, which correspond to the device names here, the 1, 2. We're just doing DD to 0 these drives, and then we give it a block count of 512 bytes with a count of 40, and that really just clears them, so you can see that's been done there. So now on the admin node, we want to set up the Ceph networks. So we want to create a directory here. So make dir-p /srv/pillar/ Ceph /stack /Ceph. So we want to edit a file called cluster.yaml. And I'm going to put in 2 lines here. We're going to define the cluster network, and if you recall, that was to be 10.10.17.0 with a mask of 24. And then we could define the public network with the third octet of 16. So just check that, and that's okay. So let's save that. We need to change ownership on this file to be salt. So chown, and we'll do a recursive salt. Okay, so now we've changed the ownership to be salt. The next task is to install the deep-c package. Okay. The next task is to edit the deep-c minions file, And this gives us the node names of all the various minions that will be deployed to. So there's a number of lines that are already present in this file. What we need to do is to modify it for our node names. So what you can see here is I've uncommented the deep C minions, and I've changed the specification here from SES to say Suse wildcard. So when the system runs, it's going to pick up the minions to be anything with the name Suse followed by whatever. So in our case it would be 00, 01, 02, 03 and 04. So we need to save that file, and this shows the importance really of structuring the node names. So we'll just verify connectivity with the salt command. So salt is a little bit like Ansible or some of those other deployment tools that you may have used in the past. So we'll put in a wildcard here, and you can see that it's picked up all 5 nodes: Suse 03, 01, 02, 04, 00. So you can see that this is done asynchronously, so the order can differ each time you run this. So now that we've made sure our connectivity is fine, we can start to deploy Ceph. This is done in a number of different stages. So the first thing we want to do is do the preparation stage, which will check for updates and things like that as well. So the command is here: salt-run state.orchestration ceph.stage.prep. So again, it's the preparation stage. So we'll hit enter. Okay, we can see now that the preparation stage has succeeded. Nothing has failed, and that's exactly what we're looking for. So during deployment, it can be useful to get a little bit more information about what's going on. So the deep C monitor command will allow us to do that. So we'll open a second window for the admin node here, and I'll run this privilege command deep C monitor. So the system will sit there and it'll wait. So we'll go to the other window, and we'll start off with the discovery phase. So as this progresses, you can see that the monitor will tell you what's going on. So this could be useful for debugging as well. So we can see that this phase succeeded, no failures. It checks to make sure that all the minions are ready. Basically, it looks like all the updates are in place, and it says everything is ready for deployment. So now that the preparation and discovery phase have been completed, we need to tell the deployment a little bit more about the roles that each of them will play. So we need to edit this file up here, policy.config. Now this is a file that you'll have to create as well. So if we look at this, we can see that we have different node names there. So Ceph cluster will have all the nodes in them. For the administration, we've picked Suse 04. We're only using one monitor in this deployment, which is Suse 00. That will also fulfill the manager role as well. On the storage nodes, everything with Suse 0 will be effectively show all the nodes, so they'll all participate and supply OSDs. The metadata server will be 00, and the iSCSI and the Rados gateway will be Suse 01. So making sure that we haven't made any syntax errors, we can save that file. And now we can start to run the stage. So earlier we did the preparation stage and discovery phases. We can also deploy these just using the numbers. So the preparation was 0, the discovery was 1, and this stage now is simply 2. So this is easier than remembering all the longer words. Okay, so that's starting to run now. You can see that networks have been picked up as we defined earlier. So the public network is 16 and the cluster network is 17. So that's good. Alright, we can see that the stage has ended, and if you look over we can see 15 succeeded, nothing failed, so everything looks good at this point. We can check the various roles with this command, so basically sort wildcard pillar.items, and let's just pipe that into more so you can get a bit of an idea what's going on. So the first node we see is Suse00. The available roles you can see here are storage, admin, monitor, metadata server, manager, and a number of other ones here as well. If we look at the cluster, the name of the cluster is Ceph, which is the default. The cluster network which we defined is .17. The minions are anything with Suse on it. There's a few other things here that doesn't really concern us. We can look at some of the other various things like Prometheus. If we keep going along, then we can see the next one, Suse02. These are the available rows, and we'll just keep going on here. So Suse00 and so on like that. So one of the major differences between version 6 and version 5 is the disk configuration section, and this has changed quite a bit if any of you have deployed it with version 5.x. So the main file itself exists as /srv/sold/ceph/configuration/files, and the file is drive_groups.yaml, and you can edit this to change things. So if you want to put let's say the DB or the wall files on different devices, this is where you would go to edit it. So this is the default file. Let's just have a quick look at that. And really what it's telling us is the data devices size is 20 gigs. For the DB devices it's put a size of 10G. These again are defaults and so on. But really what's uncommented here are that anything that has the storage role will be used to deploy data devices. So we're going to stick with that as it stands. And what we can do next is we can just go back and just verify some of the roles here, make sure that everything is set up for storage. So we'll grep for the word storage. So you can see here that Suse01 storage role here, Suse04 storage role, and all the way up. So that command tells you that the roles are all available. So we can use this command just to look at the proposed OSD configuration. So let's run salt-run disk.list. So you can see no valid JSON. That's fine because we have no cluster deployed. Let's just scroll back up to the top here. So Suse00, you can see /dev nvme0n1 and nvme0n2, and it tells you no OSD detected, but it will be created. So everything is fine. We don't have separate journal or wall devices. Same thing for Suse01 and all the way down. So that looks good. Now, because we're running with the restricted hardware and the number of nodes, and we've only deployed one monitor node and one manager node, we need to override the default. Suse will expect more than one. So we can set an environment variable to tell us that this is really a development environment, and then allow us to run that. So we need to edit this file, server pillar ceph stack global.yaml. And what we need to do is to set this environment variable telling us the development mode that we're using and set this to true. So you need to put in this line here. Save that file and then we can run stage 3. So let's just do that, and there we go. Now I deliberately ran this to show that this error can occur. The Suse current documentation is a little bit vague on this, and it says that you may encounter this error. So I did put it in just to let you know what could happen, and now we'll talk about the workaround for this that Suse describes. The workaround is to edit that same global YAML file that we did earlier. So let's go in and edit that. So we need to add this line subvolume underscore init colon disabled. So add that in and then save that file. So we need to reread the file, and let's issue this command here, sort util dot refresh underscore pillar. So now that we've done the refresh, we can run stage 3 again. You can see now the subvolume section, it says skipping. Also the development environment variable is set to be true, so let's pick that up. Alright, so that looks like everything has been completed. Enable profiles, succeeded 42, failed 0. Alright, that looks good. Now if you encounter any problems running this, make sure the syntax of the global.yaml is correct. Make sure that if you have the workaround for the missing subvolume, make sure you've got subvolume underscore init colon, put a space after it. Make sure you've no problem with your device development and variable setting to be true as well, with the uppercase T for the true. If that's correct, then everything should work fine. At this stage, many of the Ceph services still remain to be deployed. However, we should be able to see the basic cluster running, and we should be able to see if the OSDs have been deployed properly. So what we'll do is we'll look at the status of the cluster. So we can do ceph-s for the status, and if we do the watch command, then this will repeatedly update it. So we can see that the cluster is running. It has an ID. This is a unique ID identifying the cluster. Health is okay. We did only, I guess we only deployed here one daemon. It's reached quorum, and that was on Suse 00. There's one manager also running on Suse 00, and this is really key here. We've got 10 OSDs, 10 of them are up, and they're all in, so that's good. So far we haven't created any pools or any objects or anything like that, but we have a number of our OSDs, and it says 190 gigabytes available. Well, we actually made 10 OSDs of 20 gigs each, so that's approximately correct. The next phase is the services stage, which sets up the servers such as the iSCSI and the RADOS gateways. So this is stage 4. Right, we can see that a number of the servers have started up, and looking at it we see succeeded 29, failed 0. So let's look at the Ceph cluster again. Now we can see a little bit of a difference here. We've created some pools, so these pools are ready for the RADOS gateway, and we can see there's a number of default objects that are there. The placement groups are 480, all active and clean. And there's a little bit of I/O going on in the background. You can see this here. So everything should be good at this point, and that's the cluster deployed. So looking at the pools in a bit more detail, we'll go back to the command line. And you can see there pool 1 iSCSI images, then we have CephFS data, so this for the Ceph file system. The metadata of the file system is pool 3, and then we can see a number of Rados gateway pools which are necessary as well. If we want to look at some of the services that have been deployed, we look at the manager services, so Ceph manager services. And we can see the dashboard, Suse00, excelsis.io, and the port is 8443. So I can right click on that and I can do open link. And this will bring it up in a browser, and we should be able to log in and get in there to see what's going on. We'll get a warning here because of the security risk, so we'll select advanced. We need to accept the risk and continue. And then this will give us the login screen. So before we can log onto the dashboard, we need to get the credentials which will tell us the password. So the command up here, sol-call grains.get dashboard creds, will get us the credentials. So now we can see that the password for admin is given there. Let's highlight that and just copy that into our buffer. So we'll enter admin as the username and we'll paste in the password and select login. And for our case, we'll save the password. Now we've got in the dashboard an overview of the Ceph cluster. We can see the health's okay, 1 monitor node, we're in quorum, 10 OSDs, 1 manager, 5 hosted total, so this corresponds to Suse00 right through to Suse04, 1 object gateway, we have a metadata server, 1 iSCSI gateway, and we can see that little bit of activity here. If we scroll down, we can see the 7 pools that we talked about, and we can see the raw capacity, number of objects, healthy. So these were the PGs that were created as well. So that gives us an overview of the cluster itself. If we look at cluster here, I can go into a little bit more detail, select hosts here. You can see the different nodes and you can see the services or the roles that they've been deployed. So we can see that OSD 0, OSD 1, all the OSDs and so on are here. And then the second OSDs are done as well. And you can see the way the numbers are being distributed. 0, 1, 3, 2, 4, 5, 7, 9, 6. So the redundancy will be such that when we create a pool with 3-way replication, it will use 3 OSDs that are on different servers. If we had some I/O going, we could have a look a little bit about the performance, but we don't have anything set up for that yet. If I look at the monitors, now we only had 1 monitor node, which was Suse00. You can see a little bit of information here, such as the port and the IP address, which is correct. We're using actually Nautilus for Suse Enterprise Storage 6. And we could click really on Suse00. It just gives us a little bit more information here. We can see some of the fields. Here's the field name, and then we've got a description, then the values for them as well. We can get a lot more information here as well by going to these different tabs. So again, Paxos is used for the quorum algorithms. You can see a lot of information here as well. So I'd encourage you to play around with some of these and get a little bit more detail on them as well. If we look at the OSDs, we can see all the various OSDs here that are running. We can look at the usage, number of placement groups on each of them. If there was I/O going again, we get a little bit of activity there as well on them as well to see what was going on. If I click on any of these here, you'll see that we get a bit more information below. So I can see the attributes. I can look at metadata here. Again, there's other things like performance counters, and if you had these enabled, you get a lot more information as well. So the status here also shows us the cluster-wide flags. This is where we can set OSDs out if we want to, and we can look at how they're all working. So again, not much happening really. Later on we'll get some performance and you'll see the histograms varying as well. Let's just scroll back up again. And then we shall have a look at the configuration. So some of these may be familiar to you, some of them may not. Again, there's quite a lot of sheets we can open to see what's going on. So, for example, we're sending these log lines to a file that's been turned on. Again, lots of information here. If we look at the crush map, which is something that we would do later on, we can go in and look at that. We might want to edit the crush map for some particular configurations, or maybe we want to change the replication to be fine with two-way replication rather than three. So there's a lot of information we can do there as well. Manager modules, well, basically these are the modules that have been enabled, the dashboard, which is what we're using now. I/O stat is another one where you can get some of the I/O statistics out of the Ceph cluster. And then if we want to look at some of the logs, some of those will be available. Go in a bit more detail into the pools. So let's look at for example, I think the iSCSI images pool. We can look at that. All these use the three-way replicated rules. This is used for RBD, so for block devices. The file system pool and the metadata pool are used for metadata, so the PGs required for the metadata pool is quite small, but the file system one where we store the data is much larger. Again, we can click on any of these and get a bit more information as well. So that's pools. We can select block, we can come in there and we can create different block images, NFS, various file systems. We can look at the gateway and do a number of other things. So that's the Ceph dashboard. And that brings us to the end of the tutorial. Thank you for watching.